Hello everyone. Today I'm going to go over 3.5, which is non-homogenous equations and undefined coefficients. So you can write the directions for example 1 while I talk a little bit about the lesson. So in this lesson in particular, I think the best way to learn it is to do examples. At least in my opinion, there are a few steps that you can learn just by doing them over and over again, but that's just my opinion. And so let's move to example 1. Find the general solution of y double prime minus y prime minus 6y equals 2 sine of 3x. Okay, so if you think back to 3.3, this actually might look familiar. The only difference is that the right side was equal to 0. That was called the homogeneous equation. When you add a function to the right side, in this case 2 sine of 3x, you get a non-homogeneous equation. Okay, so the formula for the general solution is simply y equals y sub c, which is the complementary solution, which is what you solved in 3.3, plus y sub p, which is the particular solution, which is what we'll learn to solve today, where y sub c is the solution of the homogeneous equation and y sub p is the solution to the non-homogeneous equation. Okay, so step 1 is to solve the homogeneous equation. And you might be thinking, there is no homogeneous equation here. You just said this is a non-homogeneous equation, this is not 0. But the way we can, make this homogeneous is just setting that right side to 0. So the step 1 is to set that right side to 0 and solve the equation. So solve y double prime minus y prime minus 6y equals 0. Now, the way we do this is for every time each y term is differentiated on the left side, we raise a new term to that power. Since y is has been differentiated twice right here, we go r squared minus r to the first power, because it's y prime, minus 6r to the 0 power, and that's equal to 0. And we can just solve this by factoring, and we get r minus 3 times r plus 2 equals 0, and r equals 3 and negative 2. Now if you remember, there are a few scenarios that we could have gotten to after solving for r. This one, we found multiple real solutions. There were a couple others, which was finding one real solution, and which was finding multiple imaginary solutions. There are formulas for each of those scenarios, and for this scenario, it is y sub c equals c1 e to the r1x plus c2e to the r sub 2x, and we know r sub 1 and r sub 2 are just 3 and negative 2, so y sub c equals c1 e to the 3x plus c2 e to the negative 2x. Okay, so we have y sub c, and now we have to move on to the next step, which is obviously finding y sub p. Alright, step 2 is solving the non-homogeneous equation. So it would just look like the original equation. So step 2, solve y double prime minus y prime minus 6y equals 2 sine 3x. Now, this is a little bit more tricky, a little bit harder than solving the homogeneous equation, and so I'm going to separate it into different digestible chunks. That's how I like to think of this process, and I suggest you to, it's not necessary, but I think it's a good thing to do. So the first chunk, chunk A, is the most tricky part of this process, in my opinion, and it is finding So find the form of y sub p. Now the method of doing this is kind of tricky because there's no concrete way. There's no formula for it. There's no mnemonic device like lefty right plus righty left. There's nothing you can use to always get a consistent answer. It's more of an intuitive thing. And so first I'm just going to show you what it is. So in this case, y sub p equals a sine of 3x plus b cosine of 3x. And the way you actually find it is by only looking at the right side of the non-homogeneous equation. Now, this actually, I hope this makes sense, because we want to find y sub p in the form where the derivatives of this right side can all be found in this formula, or not formula, but in this equation. And the right side, if you differentiate it a million times, you'll always be able to find it in here. And so that's kind of the logic for it. And the goal is to solve for a and b, which are both constants. And so that's why you want the right side and the derivative of the right side to all be within this formula right here. Okay, so moving on. Well, I'll touch on this later, and hopefully doing it more will make you understand it a little bit better. Part B, or the second subset of this process, I guess, is to derive what we just found, y sub p, as many times as y is differentiated on the left the most times. So I'll just do this, y differentiated n times, as a short. Hopefully from this you can see that on the left side, the most times y was differentiated was twice, and so we have to differentiate y sub p twice. It's pretty straightforward. So let's find y sub p prime. The first term is a sine of 3x, so the derivative would be a times the cosine of 3x times the derivative of the inside term, which is 3. So 3a cosine of 3x plus b times the negative sine of 3x times the derivative of the inside term, which is 3 again. So plus negative 3b sine of 3x. Now let's derive it one more time. Y sub p double prime is equal to the derivative of the first term, which is 3a times the negative sine of 3x times 3. So it would be negative 9a sine of 3x plus negative 3b cosine of 3x times 3. So negative 9b cosine of 3x. Okay, now this is a very important list of equations we have. We're going to come back to it. And so I'm going to put it off to the side and move on to the last step in the process. I'll put it here so we can come back to it. I'll call it part C. And it is plug in derivatives of y sub p into the original equation and solve for the constants. In this case, the constants are just a and b. Okay, so if we look back at the original equation, we can see that it is y double prime minus y prime minus 6y equals 2 sine of 3x. And what it means to substitute the particular solutions, or y sub p, into the original equation is for the corresponding derivatives, you want to plug the particular solutions for the y double primes and the y primes and so on. So you'd plug in y double prime, y sub p double prime for y double prime, y sub p prime for y prime, and y sub p for y. And then you would solve for a and b. So let's do it. First, we just have y double prime, and so we substitute y sub p double prime in it for it. So we have negative 9 a sine of 3x minus 9b cosine of 3x. Okay. Then we have minus y prime. And so we plug in y sub p prime, which is 3a cosine of 3x, and it is minus y prime. So we do minus 3a cosine of 3x minus 3b sine of 3x. And finally, up here, we have minus 6y. And so we substitute y sub p in for that. So minus 6 times a sine of 3x plus b cosine of 3x. A sine of 3x plus b cosine of 3x. Okay, and all of that is equal to 2 sine of 3x equals 2 sine of 3x. Right, I'm going to get a piece of paper. I don't need this stuff anymore. Okay. Now, all we have to do is solve for a and b. So, actually, having the paper would be helpful because we need to combine like terms to make it so that we can actually solve for the coefficients. And the way we do that is we look at the first term, negative 9a sine of 3x. And are there any like terms? Yes, there are. There is one like term right here. Negative 6 times a sine of 3x. So negative 9 minus 6 is negative 15 times that term. So we have our first term. Negative 15 sine a sine of 3x. Let's look for the next term. We have, and let's go a sine, b sine, a cosine, b cosine. Let's just go in chronological order, like with the terms and stuff. We don't have to, but it makes it easier. So let's do it. Okay, so let's look for the b sine term. We see 1b sine and nothing else. So minus negative 3b sine of 3x. So it's plus 3b sine of x. Let's do that. Plus 3b sine of x, sine of 3x. Let's see if there are any other like terms. Nope. So let's go to the cosine terms. We see that there is one cosine a term, so it's minus 3a cosine of 3x. And we see that there are two cosine times b terms. So we see that there's a negative 9 and a negative 6. So it's minus 15. Minus 15b cosine of 3x. And all of that is equal to 2 sine of 3x. All right. Now we do not need this paper. Okay. So now all we have to do is make a system of equations to solve for this. As we can see, there is no cosine term, so we can just write 0 cosine of 3x, and that makes it a little simpler. So let's do it. We see that the coefficients for the sine terms are negative 15a and 3b, and the coefficients for the cosine terms are negative 3a and negative 15b. And so we want these coefficients to equal 2 and these coefficients to equal 0. And I hope that makes sense. Negative 15a plus 3b equals 2, and negative 3a minus 15b equals 0. Okay, I think the best way to do this would just be to multiply the top by 5 and then add that to the bottom. And so we get negative 15 times 5, which is negative 75, minus 3 is negative 78. So negative 78a plus 15b minus 15b is 0 equals 10 plus 0. So equals 10. Divide both sides by 10, or by 78, and you get a equals negative 5 over 39. I simplified just a little bit. So that's a negative 5. Sorry, negative 5. Okay. Now let's solve for b. If this is negative 5 over 39, we have negative 3 times negative 5 over 39, which is 15 over 39a, equals 15b. And so b would just be 1 over 39. Okay. Now we have a and b, and all we need to do is plug them back in to the particular solutions that we found at the beginning. Okay, so here it is. Y sub p equals a sine of 3x plus b cosine of 3x. And remember, all we need to do after that is add it to the complementary solution. So y sub p equals a sine of 3x, so negative 5 over 39 sine of 3x plus b cosine of 3x, 1 over 39 cosine of 3x. Alright, now we have the particular solution. All we need to do now is find the general solution. We're not done yet, but that's the easiest part. Remember, the general solution was just y equals y sub c plus y sub p, the solution of the homogeneous equation plus the solution of the non-homogeneous equation, and that would just be equal to, let me see if I can find it, this little thingamajigger right here, which is c1 e to the 3x plus c2 e to the negative 2x. I will write that down. c1 e to the 3x plus c2 e to the negative 2x, and then add that to the particular solution, which is negative 5 over 39 sine of 3x plus 1 over 39 and cosine of 3x. That's a little messy, but whatever. And that's it. That is example 1.